All right. Here is question one of Recitation 7, and we are asked to calculate thermal efficiency and the coefficient of performance of the following cycles and determine if it's reversible, irreversible, or impossible. So, if it's reversible, we know that the thermal efficiency equals to the Carnot efficiency. Okay, Carnot or reversible, and irreversible, where it's the Carnot efficiency is larger than the thermal, and it's impossible when the thermal is like larger than the reversible because the Carnot cycle is the peak of the cycle, so it can't get better than this. This is the highest it can get. So if it's higher than that, it is impossible. Okay. So looking at this, we have a steam powered cycle that has 10 kilojoule, 1000 kilojoules Q in, and it produces 600 kilojoules. So this is working it out. Okay. And we have two thermal reservoirs of, this is TH, T high, and 20 is T low. Okay. So we can just do the cloud thing that they probably teach you in class. Um, and here is our system. Let me just copy this. Okay. And we say that this is the high, so this is 600. This is the low, so and it was 20. Okay. And we say Q in and Q out, and then working it out. Okay, so this is our system. So for our thermal efficiency, we know that it's working it out over Q in. And that would just be 600 over 1000, and that is 60%. And for our reversible, or the Carnot, it would be in your equation sheet. So you would just use TH minus TL, so T high minus T low over TH, or you could say 1 minus TL over TH. Okay? But these values are in Kelvin, okay? And we have them in Celsius, so we have to change that. So T high equals to 600 plus 273, and equals to 873, and T low is 20 plus 273, and it's 293. And if you just take that, so 873 minus 293 over 873, and all of that would equal to 66.4%. And because this is larger, it would be irreversible. Okay, so this is so now for part two, we have a refrigeration cycle of 10K work in, and it provides 120 of cooling in the room. So this is QL, right? Yes. And the room inside the interaction outside the temperature of, this is TL and this is TI. Okay. So now how it is different. So instead of using Q in and Q out, you use QL and Q out. So, and this is not working it out, it's going to be work in. Okay. So we have just change the degrees. So this is 15 now, and this is 40. And it goes from the QL, okay, and it goes QH. And this is work in. Okay. So this is for a refrigerator, and a refrigerator is the same cycle as a heat pump. Okay. But instead of using QL for your efficiency, you'd use QH. That's the only difference between a refrigerator and a heat pump. So, looking at this, we know the coefficient of performance, because refrigeration and heat pumps use coefficient of performance instead of thermal efficiency, and it is QL over work net in. Is it work net in? And that would be just 120 over 10, and equals to 12. And the COP of a reversible equals to, from this formula, is TL over TH minus TL. TL over TH minus TL. And that would be, just convert everything to Kelvin, which is 288. And 40 plus 313. Okay, so it's 288. And that would equal to 11.52. And because this is larger, so 12 is larger than 11.52, it is impossible. Okay, now for question 2, we have we have an air conditioner with a coefficient of performance of 3 and consumes 1 kilowatts of electricity. So this is our work in. And determine the rate of cooling provided to the air in the room. So cooling just means Q low or QL. Okay? Provided by the air. So COP equals to QL over work net in, which equals to 3. And so, and then our work net in is 1, which equals to QL over 1. We just say QL is 3 Q dot. These are dots because it's in kilowatts. It's just 3 kilowatts. And yeah, that's all.